Andrew, Paul, would you like to tell us a bit about yourselves, please, today?
Yes, sorry, I'm Paul Burton. Am I on? Working? Yeah, well, both Andrew and I with Rosen UK. There's a little bit of an introduction on that in this presentation. We've been with Rosen UK for about 4 years, working on the integrity solutions side of the business. And obviously, integrity flexibles and the integrity management of flexibles falls into that. And so really this is an initiative we've got around how to go about inspecting flexibles using inline inspection equipment. Andrew's really the specialist on flexibles. I'm a little bit more a rigid pipeline integrity guy, to be honest.
So the audience, a little bit more about what your talk is about today, Andrew.
So the main bulk of the talk today is about using the ILI technology for the inspection of flexibles.
We record because that's why we need the microphones.
Yeah.
In-house mics don't always pick up the talks.
So the presentation today is about ILI technology for the inspection of flexible pipes. We've been working on technology for a couple of years now. And really what we're doing here is presenting where we are with the technology, but at the same time we're trying to get some feedback from ourselves on what you would like from the technology, what your challenges are, what your needs are. And it varies significantly across the industry. So it's obviously multiple challenge to select the correct technology all the time.
Okay, thank you, Andrew. And Rebecca, can you tell us why this is of interest with OGTC, please?
So some of you are aware of the work that we do here at OGTC. So flexible risers is a challenge area, technical challenge area that we are looking at. And we know that a lot of them are reaching beyond design life. They're difficult to inspect. There are challenges associated with managing the integrity of them. So anything that can be done in this space is obviously an interest to us. We're here to support technologies that will help overcome those challenges. And also getting the background, getting people's thoughts. When we come to the Q&A, it's not so much just Q&A, it's about even just sharing anybody's experiences so we understand what those challenges are, so we bring the right technology and the right solutions to hopefully people that are interested and have some knowledge and background in that area.
Okay, well, thank you very much. And Andrew and Paul, your 20 minutes start now.
So just a quick overview of the running order, and a very quick introduction, and then from me a little bit of an overview of the rigid pipeline integrity world, and how we go about managing the integrity and inspection of rigid pipelines. I'll hand over to Andrew. Andrew will do a similar thing from a flexibles perspective, and talk a little bit around the initiative that we've been working on. We're on the clock, so I'm not going to hang about. Rosen UK, we're part of the integrity solutions business field within Rosen. As you can see, Rosen do quite a lot of other things, but I don't really want to go into that. We do have an office just across the street, set up by Bryn Road, so I guess quite a few of you might know Bryn, but so we are literally just across the street in Aberdeen. Andrew and I work in the Newcastle office. We've both been with Rosen for around 4 years, actually, and in that time we've come to realise that Rosen have quite a big R&D capability within their organisation. In fact, 15% of Rosen's staff actually work in R&D. It was quite a surprise to me and to Andrew, I think. So we've been, over that time, wondering how we can get some of that R&D effort deployed to look at flexibles. So really that's what this story is about. Actually, not only did they have quite a very big R&D facility, this is actually the facility in Germany. They also have a factory where they actually manufacture all of their own inspection equipment. So on this site, they've got around 1,000 people actually employed, so it is quite an impressive facility to get to go to. Of course, we're talking about flexibles, but before we get into that, just a little bit of an overview of rigid pipelines and how we go about things for rigid pipelines. Now, this, well, I think the picture shows it, and they've been around for a long time, over 100 years. Carbon steel pipelines, maybe not necessarily carbon steel, but they've been used for the transport of bulk transport of hydrocarbon fluids for well over 100 years. As you can see there, quite some interesting construction techniques in the early days. But because they've been around for a long time, we've got a very good understanding of the integrity threats that can impact on pipelines. that's a good list from, I think, PD 8010, one of the codes that exists that really categorises well the threats. Yeah. Onshore, we worry a lot about external corrosion and also mechanical damage from third-party interference. Offshore, we tend to worry a bit more about internal corrosion, but also interference from external sources. We know a lot about the failure modes and degradation mechanisms for pipelines. There's even an encyclopedia, the pipeline defects. Rosen UK, former name of core engineering, some of you might remember as that was our own publication. We also know what happens when pipelines fail. It can be quite catastrophic. Obviously, these are over periods of years, but it gets into the news, and this drives a lot of the regulation, the codes and standards that exist today around the management of the integrity of pipelines. Fortunately, we've got a bit of an ace tool in the box, the inline inspection tool. In fact, we've actually got quite a lot of different types of tools now. We've got tools, obviously, to detect the presence of corrosion and metal loss, but we've got tools that also look at deformation and mechanical damage, tools to look at things like cracks, tools to map the centre line of the pipeline, the XYZ coordinates, looking for the displacement of the pipeline, crack inspection tools. There's a whole range of tools that are now deployed in the rigid pipeline inspection world to address the threats that we're aware of. We get loads of data from these pigs. Gives us a very clear picture of the condition of the pipeline. Not only do we get loads of data, if we do multiple inspection runs, we can do very detailed comparisons between over different periods, so we can look at the degradation rates, corrosion growth in this case. That gives us an idea how long we've got left remaining life for the pipeline. So really we can do a lot with this data. These days, inspection tools, the resolution is increasing all the time, a little bit like 4K on your telly. We can do quite smart things now. Obviously, we can render inspection data into quite detailed 3D images now. How useful that is, I don't know, but it just gives a demonstration of the level of resolution that we can achieve now with some of the magnetic tools that are on the market. So yeah, we've got a lot of tools in the locker. And Andrew, I know, is feeling a little bit impoverished about this from a flexibles perspective, because at the moment there isn't really that level of inspection possible with a flexible. So since his time here, Andrew's been working hard to get some attention within Rosen to come up with an intelligent bid for flexibles. So I'll hand over to Andrew. He'd like to talk about that.
So I guess brief background, the pipeline on the right hand side, there's the blue pipeline. At the end of the Second World War, it was used to move diesel from England to France. And obviously a standard flexible pipe structure that's evolved from probably the mid-1980s, following the API 17G of the ISO standards. They are predominantly all around the world now, using all floating assets, so they are key production, and they need to be managed in a way which means they can extend the life or mitigate for failures. So at the moment from inspection technology, there is about 4 brands you can put them into: internal visual inspection, cameras; external visual, with your ROVs; external NDT methods. There's certain technology for external flexible pipe to measure certain aspects, and analyst testing being one of the most common ones as well. But they only give part of the answer, and obviously if you don't get the answer right, you can end up with significant failure occurring. So why do we look at technology? And obviously the technology from a flexible point of view now is to remove uncertainty. All the technology on the left hand side, probably from about 10 or 15 years ago, are driving to remove that uncertainty. If you don't remove uncertainty, you've got production, reduction, you have to limit the vessels, run some risers or flow length for certain aspects, medical replacement or even decommissioning, which drives costs and replacement drives costs. So we're going to look at ILI tools for flexible pipes. There appears to be a series of systems available. There's a standard piggable system. It's got a launcher at one end and you see you've got the other, where you put the pig in and away you go. Pigs also have the benefit of being bidirectional, so you can pump them down flexible and return them back from a production point of view. And some systems just obviously can't be inspected directly with a free pig, you might have to look at trawler systems. These are solutions that Rosen have available. So this brief background on why we're looking at layers and why we're looking at them. This is an extract from the SureFlex GIP, which was from last year. And when you look at the review, you come up with 4 groups. And the 4 groups we've got are the carcass layer, the pressure sheath layer, the tensile and pressure, and annulus flooding as a group. But the annulus flooding is so impacting on the tensile pressure how much you could move them together as one. And this gives you just a brief view of the quantities of flexible pipes that are failing. And see in the bottom corner here, there's 580 flexibles failed over the period of the time. And the groups are clearly seen there. There's 10% for carcass, you've got 15% running in the pressure sheath, and then you've got the major jump going up when you go into the carbon steel layer. So Rosen started with getting a section of flexible pipe. We've got a real life bit in Lingen, Germany. It's 15 metres long, and we've used this as our test pull-through sample. So we've been putting pigs through this section and extracting the data from it. So what I'm pulling up here is the data from an ILI tool passing through a flexible pipe. So on the right-hand image, you can see the start of the flexible pipe. Then you've got the main body through the end fitting, and then you've got the carcass wraps, and it's depicted on the bottom image there. And on this image here, with what we've got here, we've got a visual inspection of that bore. I'm just pulling up the technology. It's very difficult to identify in the top image, but we are picking up very, very fine detail when you look at flexible pipes from a technology point of view of the parts there. So on that 15 metre long sample, we did some pull-through tests on there. What we were able to do, we were able to measure the pitch and gap of the carcass profile. On the bottom there, what you do have is a representation of about 1 metre of flexible pipe, while the light blues are the flats of the carcass and the dark blues are the valleys. So the technology and the software has measured them and it's logged them all out for us. There's different run speeds in here at different times, but what we'll find is we've got a pitch and gap of between 19.5 and 21 millimetres. And what you want to see for your entire flexible pipe is in reality that being maintained for the entire length of the flexible. What you don't want to see, from my perspective, is sections of compression, so it bands down for a period of time. You may find you've got a section of extension, which band up for a period of time, or even losses of interlock, which will show as significant jumps in the data set. These issues may occur at hog bends, sag bends, touchdown points, or generally just tearing of the carcass, resulting in collapse of failure or blockage of the flexible pipe. What we also want to do is look at defects which you see in more standard rigid pipelines, which are corrosion features, etc., etc. So what we've done here within the lab environment using the sensor is we've got a series of circumferential and horizontal defects in a carcass section and a couple of other little bits here. One being a weld spot defect, measured out corrosion, and the one right here for erosion. You can clearly see that from the data sets again, we are picking up the valleys of the carcass, but we're also picking up the circumferential and horizontal defects within the data. Now this might be carcass tearing from a manufacturing process. Once it's being made, you can't physically see inside the flexible pipe. It may be things where there's a horizontal weld cracks occurred with the carcass manufacturing again, not being picked up. But then the stuff that may impact more the corrosion cracks that occur during operation of the flexible pipe. So in a summary for the carcass of the layout of the flexible pipe, so we've developed a new sensor, the DRD sensor, and for us this technology allows us to again get the carcass pitch, circumferential damage, longitudinal damage, erosion and corrosion. So we're covering that internal layer of the flexible pipe now. And as you can see on the left hand side there, we've got a snapshot of the ILI tool that we used on the pull test, and the DRD sensors are mounted around the circumference of the bars. One of the important things I wanted to do when I did this exercise was to make sure we weren't losing the value with respect to the rigid pipelines. So this ILI sensor can be used on rigid pipelines and flexibles, which means there's only one tool going through a flexible rigid system or a complete flexible system. So and then there is a few in the North Sea where you've got rigid and a flexible riser or steel risers and flexible seabed, flow line in the seabed. Then this can be able to pass from one go, that's all the information. Just moving on to other data that Rosen have identified during an inspection run. One of the interesting ones would be something like the mid-water arch, or the entrance to an eye tube on a vessel. Since the magnetic field is so heavily distorted as you pass through that steel boundary, you can detect where the mid-water arch clamp is, and you can determine that it hasn't moved with respect to riser configurations. Now, the way looking forward as well is, can we do things with buoyancy modules on systems? Can we put a way to measure the location of buoyancy modules which supports the idea of loss of buoyancy module, they're bunching together, are being placed correctly during installation? Try and put all these systems together in a simple pass-through. The next area in the flexible pipe is generally the most concern, which is corrosion of the pressure element and tensile armor layers and associated fatigue and failure. And this is what's most commonly happening around the world. One of the challenges with that is it's not as easy to get to as the carcass layer. You've got to get past the carcass, past the pressure sheath, before you see the pressure element. So what we've been doing is working on sensors and technology to allow us again to measure the pitching gap, looking for losses of interlock, which is one of the main concerns for the pressure element. And then when we're looking at the tensile wires, we're looking again at the layer pattern of the tensile wire, make sure that there's a coherent pattern, there's no snapping, there's no bunching, and try to bring all that information together. So what we've done here is we've modelled this in a lab environment with a section of pipe, and we've used 15mm as an offset from the sensor to the carbon steel. It's about typical for most flexible pipes. There's obviously some smaller cases to that, and there's some more extreme distances on that, but that's a representation. So we're busy working on a new magnetizer at this moment in time to try and get that magnetic field further through the flexible pipe to collect more data and to get more data back. One other thing we're looking at, and Paul mentioned it there with respect to onshore and IMU mapping, is rigid pipelines are mapped every day for topography across the ground to make sure there's ground movement, you can pick up the strain, etc. within the flexible pipe. So what I've been looking at is saying, well, why can't I collect exactly the same information for a riser profile or seabed profile to check for strain locations? With the riser profile, we're saying, well, if we can map a riser profile, we can compare it against the original analysis, and therefore we've got a snapshot in time of that flexible pipe as it is in the water column. And one of the biggest challenges with modern flexible pipes is its bending stiffness. It varies so much depending on whether it's in a certain part of the performance curve, and whether or not it'll conform to this configuration. So we're looking at using our IMU data to map the riser, and that information can be fed back into analytical software. We run the fatigue analysis, dynamic analysis as well, but also things on the seabed, making sure there's no tight bends anywhere, it's not being kinked anywhere, and trying to pull more information from the inspection run. And I guess from the end of the presentation point of view is now, this is where Rosen are looking to move to, but obviously we need the industry to turn around and say, we've got these challenges, and how do we help support to address them challenges. So what I've presented here is obviously Rosen's highlight tool. I've also presented external technology that's there. And there's also going to be a complementary point where the technologies work together. We can pass through a flexible pipe at around 1 to 2 meters per second. So most flexible pipes are covered within 10 minutes of the ILI to entering the flexible pipe. Well, they may find discrete locations where you want to find dents on caliper tools, as we use on rigid pipelines, and then you can maybe look towards a more bespoke external technology to home in on features that you can't identify.
Yeah, I think on there, there's a list of questions. I mean, really what we want, I suppose our objective to come here was to share what we were doing, but B, sort of get a bit of input from you in terms of, are we on the right track? Is there anything else we should be looking at? We mentioned polymers down there. I know people are concerned about the polymer layers in flexibles, and that might be a harder thing to do, but there are things you can do with ILI technologies on polymers. It's easier to work with the metallics because that's what people are used to looking at. But so I think what we would like is a little bit of input from people in the industry to give us some direction.
I was just going to ask, have you done any work on flooding detection within the
Yeah. That's probably a good question, and I think we're trying to work out what's possible from an internal perspective, from a pig. And Andrew might know better than me, but I think we're looking at maybe some kind of an acoustic sort of ping where we get a different reflection if the annulus is flooded or if it's not flooded. And I think we're in the early stages of thinking about that. That certainly is a direction that we're going with.
One of the challenges with an internal method is pressure that people may run in the pipeline after technology or, for example, UT challenges, pressure-related challenges, as it would be when you get to the higher end. But it would be the ideal scenario that you investigate all the layers in the flexible pipe, and we've started with the first one being the carcass, or looking at the pressure arm layer. But what we see is, if we understand the information for the layer above, we can maybe bring in different approach to the layer below it, and by combining the knowledges of all the layers together, try and identify them defects, and in the end, identify the failing mode that goes with that defect. Widgets has got their trap methods and their corrosion growth methods. They don't really exist as much for flexible pipes. An identification of the feature and then sizing it to means of failure is the next challenge.
Yeah, I mean, it is quite challenging, and it's been quite hard to keep the Rosen guys on task with it because they've got lots of other things to do. That's one thing, but also I think when they start, Rosen did look at this before we ever turned up, and they concluded it was just too hard and they couldn't get any useful information out of it. But what Andrew brought to it was, well, what are you looking for? Because these are the failing modes, these are the things that go wrong. And even if it can do that, it's useful. And we've been bringing them along, and now we've got some really good interest in it within the Rosen R&D facility. So we're really pushing for the next step. Annulus plugins, of course, I mean, currently there are methods, annulus testing, where you can do things from the external, and it may be that we can do something internally as well. I hope so.
Yeah, is not the challenge that you're looking for a very small amount of salt water in a very dense metal magnetic structure? Deep carcass,
yeah. I mean, I would guess that what we would be able to see is the start and the end of a flooded section in a riser based on a different reflection from an acoustic transmission or something. So whether we can distinguish what was in there is another matter, actually.
I mean, I still think identify that there is an external method for doing that, for flooded detection. The drive for internal may be less, but that's what the market's there to tell us.
Yeah, no, but it's good feedback. Yeah.
Can I ask about launching tools?
Sorry to interrupt, that's our 20 minutes up.
Yeah.
So thank you.
But we're into questions now.
So thank you, Andrew and Paul. Hope everyone found that informative today, and now we'd like to open up the floor for questions. But may I ask, because we're recording, please wait for the microphone before you present your question to Andrew and Paul. Thank you. Thank you. Round of applause. Thanks. Questions?
Thanks, guys. Really good presentation. Looking at the carcass images, is that taken via NFL? Looks like an ultrasonic.
I know it's an eddy current technology.
Interesting. Yeah.
Use that.
Okay, we'll pick up on that later, but yeah, that's good.
I know the SureFlex report mentioned UT from a technology point of view, and we haven't been able to identify the best solution for UT doing that. We've identified these solutions as the best solution to the system.
Yeah, great presentation, guys, thanks. Launching a tool, flexible risers tend to be fairly kind of enclosed systems, so if you give much thought to actually going to deploy tools.
Well, that's the biggest challenge to the industry, or to launch a flexible pipe, is the natural configuration of flexible pipes that aren't designed for island tools. There are a few which are rigid to flexible systems, and there's a few in the North Sea. There's a few more within here West Africa where there's rigid pipelines on the seabed, and therefore they need to be inspected, so it's natural to capture the flexible pipe data. When you look in the North Sea in general, though, flexible pipes are isolated systems. They don't have that natural pigging loop in there. There is options of doing pump in and produce back, for example, or we have crawler systems, so the risers turned off and we can crawl down. Data set information changes obviously based on that. But the technology can be done, not as easy. Not as easy.
Cheers.
guess from the liability point of view, the CARCASS profile you've seen there is the area that probably has the most interest right at the top of the riser anyway, so you actually dropping in and kind of take back out is probably quite a good route in.
It is. I mean, there is some instances within the North Sea where CARCASS fall in that region. But what we're looking at as well is, if, for example, on touchdown points, you see a lot of CARCASS compression or CARCASS extension, can you look to understand what's happening on the overlying layers for that to be occurring?
Yeah.
You've seen, if for example, if you could look at the pressure armor there and you could see significant amounts of extension occurring, then you'd be concerned about undue fatigue or undue loading on that layer. And you might want to look at, has the seabed changed at that point, the touchdown change, and try to re-engineer that. Look back.
So on the pressure armour and tensile armour you're now starting to look at, you said there you've got 15mm standoff.
Yes.
To try and mimic the CARCASS.
And the pressure sheets, yes.
Is that, so you say mimic it, or have you got CARCASS in place there, or is it just...
Not at this moment in time. One of the good benefits of the technology we're using is stainless steel 316, which is predominantly most flexible pipes in the North Sea. Doesn't have that much of an impact on the following technologies.
That would probably be a magnetic system.
Yeah.
So 316 isn't an issue.
There is an issue when you go to the 3 or 4 wells, which for the older assets or the duplexes, therefore challenges might settle.
Okay.
But we're not passing to flexible pipes to identify if they are significant, yes or that. I mean, the surprising thing is we can see what that's presented there, a mid-water arch, and that's just a standard magnetic field loss out. So it's coarse. Now, can we make it refined and finer?
Of course, it's a big
object. It is a big massive steel, yes.
Okay, thanks.
One of the advantages you've got now in the pigging world is that you can use combination technology. So you could put a UT, an eddy current, and an MFL system on one pig. You can do that now. So it's much more flexible in terms of deploying inspection technologies into a pipeline. So we just have to work out which are the best ones and which give us the best results and the best combination of results. And that'll take time, but we're picking the technologies and the layers off one by one and trying to push the envelope and see what we can do. It's no different to where we were in the 1960s with rigid pipelines. The inspection technology then was quite primitive and crude, and I think it was Shell together with a company, Tudoscope in America, developed the first inline inspection tool. It was probably a very coarse instrument that gave basic information, but they've come a long way in that time. So we're hoping we will maybe never get to the same level of inspectability, but maybe one day if flexibles are inspectable, they'll be made to be inspectable. So,
Yeah, that's one of the I guess the challenges and benefits of bringing the solution to the market is having the flexible pipeline manufacturer support the integrity process as well. And I know they have obviously their own drivers, their own integrity processes, but there may be solutions which can use that layer instead of that layer, which allows us to be inspectable. So it's trying to get that balance point. I think obviously moving forward as well, the realms of composite are coming through as well. And that's another step in challenge of how do you address potential failure modes within composites. And again, something like an allied technology can look at them sorts of materials.
in some senses, in a roundabout way, what we are actually looking for is help with the business case, because we do want to take this forward and we do want Rosen to continue to invest in research and development in this area. And we're not asking for money from OGTC. Rosen will fund it, providing there's a business case, and we're both trying to develop the technologies and push the idea, but also at the same time we need to develop the business case so we can keep this thing moving forward. So issues like inspectability can be a bit of a problem because enclosed systems, probably not really ideal for this setup. But we welcome anybody's feedback now or after the event on is it a business case? That's one fundamental question we've got to really ask ourselves. We think there is, and we think there's interest in this, and we're making good progress, and we want to carry on. But someone in Rosen has to put up money to do that, and we need to convince them that's a good thing to spend money on.
So I think we've obviously seen from your perspective what you're working on and what your ideas and challenges are. I would also like to potentially hear from other people to see, is there a different approach, is there a different way we can be managing integrity challenges, or is there an area that we haven't thought about? Is there a gap somewhere else? Is anybody else working on different ideas or solutions, or really getting an understanding? Or are these guys going to solve it all?
One of the biggest concerns for everyone is Andrew, and everyone who knows flexibles in the room knows, if there's an inspection technique for the pressure sheath, the industry would be very, very interested. But that's quite tough.
One thing I would say about the pressure sheet is that the biggest obviously impact for its agent is its pressure and temperature. That's we go to that. And the chemicals. Knowing or not knowing what chemicals you put along that flexible pipe is obviously a key aspect. And the coupon monitoring process at the top of the flexible pipe goes somewhere answering that question of how the polymer is aging over time. But if we can get detailed imagery of the pressure arm layer, the typical approach would be that the polymer is squeezing itself into the gaps of that pressure arm layer. Therefore, you can start looking at locations where you may have high strain occurring because the pressure arm is compressed up and it's trying to squeeze in. You may have the aspect where the polymer is generally hot and under high pressure, then you have a cutting effect on the polymer layers, and you're looking to say, well, can I get the stress razors? Can I determine if any cracks potentially occur at any locations? Ideally, we would measure some property of that polymer layer. You've got your U2 measurement in the manufacturing process, which tells you how thick it is, and that's linked to the speed of sound, etc. And if you can start looking at that from the same technology in service, then that can give you some further information. But there's very little technology used for testing polymer in a working environment anyway. So that is the challenge. But I think we can collect data on the underlying layer and the overlying layer and understand how they're interacting with that polymer layer. At least there's something else there that's there that couldn't be a risk due to nylon aging and hardening or PVDF and clapping, for example.
So what we're saying is we welcome any technology proposals for funding to come into that area.
Yeah, I guess, yeah.
Open invitation. If you've got an idea, come and speak to us. And that's what these talks are about, is really trying to understand where's gaps, where's something that we're interested in, and potentially challenging other people's ideas to see. Are you on the right lines, or are you...
I mean, I've got a question for Andrew, because I'm not a flexibles expert this way. For smooth bore pipelines, I guess there's something you can do there.
Yeah,
where there's no carcass.
With smooth bore pipelines and more carcass, which would fall under water injection for a lot of applications in the North Sea, and there's some gas lifting, gas injection, I think, some gas production systems as well from a patented product that Tech20 supplies. Then in reality, if you can put a pig along there, you can inspect the polymer much more directly, you can inspect the carbon steel much more directly, because they're much closer to start with. But the quantity of pipes in the world and the systems they're building is obviously a separate challenge. There's obviously an inherent risk of making sure the pig won't damage the flexible pipe, and obviously with the polymer, that's probably another step that needs to be considered. But you can make very soft pigs these days, that's one way to put it. So, getting that balance.
I think we've got another couple of minutes if anybody else has got any burning contribution they want to give to the room. Any other questions or thoughts?
No, I mean, obviously, I know these closed systems, I mean, you know, umbilical inspections come a long way now, so if there is an access point, even if it's not a normal pig trap and something can be done, there are umbilical systems available now where we can deploy these technologies through a crawler mechanism, and we can go, and those systems can go up to 10, 20 kilometres these days, so they could easily cover the full length of a flexible without any trouble at all. So there maybe are options for some of those difficult flexibles as well.
So I think we'll bring it to a close now. So again, once again, thank you to Paul and Andrew, and obviously thank you for your contribution today as an audience. We have one of these every Friday, so on different subjects and different topics, and different formats. Apart from you always get your lunch, so it's handy to go down on Friday. So we would welcome anybody to come along for any of our events, but once again, thank you for your time today.
Thank you.